Let's solve our question now with the math behind it. So we had our function ln of x divided by x, where x has to be positive. And we want to find out the range where the function is convex and where it is concave. And remember that in the previous video we showed that convex and concave we're dealing with the second order derivative function. But to get to the second order derivative function, we have to know first the first order derivative function. So let's do that. First order derivative function. That's ln of x divided by x derivative. Alright, so we have a division, which means that we're going to use the quotient rule. What is ln of x divided by x derivative? That's the first term derivative times x minus ln of x times x derivative divided by x to the power of 2. Alright, what is ln of x derivative? That's just 1 over x. So it's 1 over x times x minus ln of x, and what is x derivative? That's just 1 divided by x squared. Alright, what can we do next from here? X and x cancels out, so we're left with 1 minus ln of x divided by x squared. And remember, this is just the first order derivative. Now we can go on and solve the second order derivative by differentiating this thing again. So f second order derivative is the first order derivative differentiated once again. So that means we take 1 minus ln of x over x squared, which is the first order derivative, and differentiate it once more. Let's go on. So first term derivative, again, we're having a division, so we're using our quotient rule. 1 minus ln of x, that's the first term derivative, times x squared minus 1 minus ln of x times the second term derivative, which is x squared derivative, divided by x squared to the power of 2. Alright, what is 1 minus ln of x derivative? Well, one derivative is 0, ln of x is 1 over x. I mean, derivative of ln of x is 1 over x. So 0 minus 1 over x times x squared minus 1 minus ln x times, what is the derivative of x squared? It's just 2x divided by x to the power of 4. Alright, let's keep going. 0 minus 1 over x, that's just minus 1 over x. So we have minus 1 over x times x squared minus, and here we have 1 minus ln of x times 2x divided by x to the power of 4. Alright, let's do some simplifications. X and x cancels out, so we have minus x minus 1 minus ln of x times 2x divided by x to the power of 4. Let's see, what common terms do we have here? We have x as a common term, so let's take it as a common factor. We have x over here and we have x over here. So that would mean if we take x in front of the bracket, we would left with minus 1 from the first term, minus 1 from the first term, minus, and then 1 times 2, that's minus 2, and minus with the minus makes it into a plus. So plus 2 ln x, 2 times ln x divided by x to the power of 4. And that's our second order derivative. Second order derivative. Alright, now let's go back to our domain. What did we say in our domain? In our domain over here we said that x has to be positive. Alright, x has to be positive, which means that this thing will be positive always. X to the power of 4 is always going to be positive because any number to an even power is going to be a positive result. So let's have a look at this expression over here. Let's write it as 2 times ln of x minus 1 minus 2. That's equal to minus 3. Now we want to know where the function is convex and where the function is concave. So we want to know the range where this expression is positive and where this expression is negative. Well, let's see. We can find it out if we make it 2 times ln of x minus 3 equals to 0. 2 times ln of x minus 3 equals to 0. And we'll show the range on a number line. That means we have 2 times ln of x equals to 3, which means that ln of x equals to 3 over 2. Now, if we want to keep x on one side only, we know we can use the logarithmic property, where we take e to the power of both sides, such that e and ln cancels out. So we're left with the fact that x equals to e to the power of 3 over 2. Alright, if that's the case, and we put everything on a number line, and we're working with the second order derivative, remember, for the second order derivative, e to the power of 3 over 2, that's the value of x. At this point, the second order derivative is equal to 0. That's literally what we just found. The second order derivative equals to 0. Second order derivative equals to 0. Well, how can we know where the range is going to be positive and where the range is going to be negative? Well, if we give values higher than e to the power of 3 over 2 into x, we will get ranges that are positive. We will get values higher than 0. So the range higher than 0 is to the right of e to the power 3 over 2, and values less than e to the power 3 over 2 will give values less than 0. So this will be a negative range. And just to make sure, just to prove the point, let's actually give such values. First of all, let's see what is e to the power of 3 over 2. E to the power of 3 over 2 in the calculator, that's 4.48. So this value is approximately 4.48. Let's take the value of 5, a value higher than 4.48. Well, if we multiply 2 times ln of 5 minus 3, we get 0.2. 0.2 is a positive number, which means we'll have a positive range. Let's take a value less than 4.48. Let's take value of 4, and if we multiply, we're putting 4 into our x, so we would have 2 times ln of 4 minus 3, we get a value of minus 0.22, and that's a negative range. So, as a conclusion, we can say that the function is convex, so f of x is convex on the range starting from e to the power 3 over 2, and we put the closed bracket because remember we need the range where f second derivative is greater than or equal to 0, so we include this value until infinity, and the function is concave from negative infinity, we're starting from negative infinity until this point, e to the power of 3 over 2, and again we include the value because we want the range where f second derivative is less than or equal to 0. And that's it, we are done.